discharging, and it also help see how much the battery can, how much the internal resistance will affect the battery. And this is a sample of code I get from Battery University. It's a data reference. So increase internal resistance itself will affect the reduce of battery performing time. So the height from the right side, from the left side you can see that the internal resistance is lower and the performing time is longer. But see on the right side, higher internal resistance, the battery performance is reduced. Why? Because there's more losses compared to the left one. And this test I did with the two similar capacity battery. However, the internal resistance is different. And it shows us that the performing time is also different. The battery in low internal has longer performing time compared to the one with higher internal resistance. And this proves to us that the internal resistance will reduce the battery performance a lot. So when repurpose, you need to consider this better because the battery resistance is all an old battery, and we need to consider the internal resistance and ensure that they won't overheat out the battery also. Next, I'll pass on the worksheet. We'll talk more about monitoring system.
So now we're talking about the battery voltage and surface temperature monitoring system. So for the battery voltage measurements, we will be using the DC2259 block from analog devices, and for battery surface temperature monitoring, we will be using thermistors. So the DC2259 block has a measurement range of 0 volt to 5 volt, and it is capable of measuring up to 12 cells, as you can see here, and the resistors here are internally connected to the block. And the 12 cells are connected from pin C0 to pin C12. Here is the connection solid in real life. So the DC2259 port uses the SPI communication protocol, and here we have the SPI communication circuit with the SPI master device, the MyRail, and the 5000 ohm resistor here on the master input slave output pin ensures that the pin will not be floating even when it is not transmitting any data. So here we have the state transition diagram for a single DC2259 port. So first, we will need to initialize the SPI communication protocol with the SPI master, the MyRail, and the first reconfig command that we send to the DC2259 port ensures that the SPI communication circuits are properly connected. And secondly, we have the write config command. This command is used to set configuration 0 to 5, which is used as the under voltage and over voltage settings of the passive self-balancing feature of the DC2258. However, as previously mentioned by Jovan, we will be using the active self-balancing mode instead. So this feature of the DC2258 block will not be used in this project. And afterwards, we have the start cell analog digital conversion command. So this command is used to initiate the board measurements so that we can actually start to measure the voltage from the batteries. As the board measures voltage in groups of 3, we will need to send 4 commands to get readings from all 12 batteries. So we need to read group A, B, C, and D. And finally, we have the clear reading command. So this command clears out the old readings and enables the board to get new readings again. And finally, it loops back to the reconfig command to start the cycle again. So we can actually daisy chain the DC2259 board. And for the daisy chain configuration, an additional dummy command is needed to generate wake-up pulses to wake up the boards connected to the daisy chain. And the dummy is needed for every valid command of the DC2259. So here we have the state transition diagram for the daisy chain DC2259. And as you can see right here, before we send any of the valid commands, we need to send a dummy command. So the daisy chain configuration uses a broadcast command system, as the DC2259 box do not have individual addressings. And to broadcast the commands, we will need to connect an RJ45 Ethernet cable from port B of the first port onto port A of the second port, and so on. And the maximum broadcast distance of this broadcasting command is up to 100 meters. So we will also need to change some of the jumper settings for daisy chain. So for the first box will be 0000, and subsequent box will be 1110. And we will, as previously mentioned by Jovan, we've installed some system protections for the DC2259 boards to protect the boards as the range of the measurements is only 0 volt to 5 volt for each cell. So we have relays, and here we have the step-down converters that are powering up the relays. The relays will be tripped, and during system warnings when the readings exceeded the threshold settings, which I'll demonstrate during the demo session later. So we also have a smoke sensor to detect any presence of smoke from the batteries. And here we have the analog multiplexer. This is used for us to connect the thermistors that are measuring the surface temperature of the batteries. So the analog multiplexer is able to reduce the number of pins that is needed to be connected to the MyRail, as it only requires 8 connections to the MyRail. However, it enabled us to connect up to 16 thermistors in total. And the table on the right shows the commands that to send to the analog multiplexer to select the different channels of it. So the command, as you can see, the commands here are basically binary numbers 0 to 15. And here we have the thermistors, and its circuit connections are basically voltage divider circuits that are connected to one of the input channels of the analog multiplexer. And this, as mentioned by Jovan earlier, this is how we place our thermistors on the surface of the batteries. And now we're talking about the monitoring system's user interface. So this is the main lab view dashboard right here. So the first thing that the users actually do is that they should set the threshold settings for over and under voltage and temperature. And afterwards, to actually start monitoring, the users can just press the start button right here. And as you can see, some of the voltage readings here are higher than the over voltage threshold setting, and hence some of the dashboard indicators here will indicate that this is actually an abnormal reading, and it will trigger the system warning. So the system warning, it will, as mentioned, it will trip the relay, and it will also turn on the buzzer as well as an SMS message sent by the GSM modem device, which I will demonstrate during the demonstration. During system warnings, the users can actually reset and turn off the system warning. However, the system warning will keep coming back as long as the readings are still out of range of the threshold settings. And we also have a form path for data logging where the users can collect data for further analysis. So here we have the flow chart. This is for the user interface that I just mentioned. And here is the NI web server dashboard that is enabled by this 4G router right here. So it enables remote monitoring on other devices by connecting to the 4G router. So the NI web server dashboard basically functions the same way as the main lab dashboard. So if there are any readings that are still out of range of the threshold settings, the indicators here will indicate that the cell is abnormal as well. And here is the GSM modem device. And during system warnings, it will send out a system warning SMS messages to the user. These are some of the data that we've collected during our discharge experiment. So as you can see here, all 24 cells were discharged at around 3.7 volts to 3 volts at a time span of around 3 hours and 30 minutes. So and the cells were discharged at 0.2 discharge rate. So here we have the temperature curve during that, of cell 1 to cell 12 during that discharge experiment. And this is the temperature curve of cell 13 to cell 24 during the same discharge experiment. And this right here is the temperature curve of the same type of batteries from research paper from Science Direct published by Shanghai Jiao Tong University, and the batteries were discharged at 0.3 discharge rate. So we can see the similarities in our temperature curve and in the temperature curve. So in conclusion, the system is able to monitor battery matrix during charging and discharging while collecting data for the experiments. And for system projections, we've installed relays and fuse. And for system warnings, we have SMS message, buzzer, and the dashboard indicators. Overall, our system is able to evaluate battery suitability for repurposing to reduce battery waste. Thank you.
Okay, thank you, Zidane.